Recording in progress.
Sweet. All right. So the homework has shifted a little bit. So the answer keys I gave you guys a while ago, a little off. It's okay. I knew this was going to happen because I get too ambitious. Like, oh, I could cover all this in one day, and I don't, because I don't want to rush stuff, right? So I made a new answer key for this homework that's due today. So 36 is right here. I put it in Schoology as well. So hopefully you guys have it. So you don't have a hard copy of it. It's there in Schoology. Remember, I imposed a condition that I want A and H to be positive for 36, A and H to be negative for 37, A be positive, H negative in 38. And the graphs themselves are right here. So kind of toggling back and forth. If I want, well, first of all, just looking at the graph, right? Like, I mean, it's pretty obvious your A value is going to be 3. Your K value is 0. The period is pi, it looks like. Yeah, period's pi. So B is 2. The H value is going to change depending on what I want. I want H to be positive, and I'm doing sine. My H value is going to be pi over 6. For cosine, a little tricky. But if you think about it, that's a 4 pi over 6, right? So if that's pi over 6, 7 pi over 6, 4 pi over 6, what's happening between pi over 6 and 4 pi over 6? Best convert that to a denominator of 12. 2 pi over 12 and 8 pi over 12. What's happening between 2 pi over 12 and 8 pi over 12? 5 pi over 12. I know, so you got to think a little harder about that one. So does that make sense? Pi over 6, 7 pi over 6, that's 4 pi over 6. Convert those to a new fraction of 12 as a denominator. 2 pi over 12, pi over 6 goes to 2 pi over 12. 4 pi over 6 goes to 8 pi over 12. Half between 2 and 8 is 5. 5 pi over 12, boom, there you go, you got it. That's how you want to write it. So I'm just trying to challenge you guys, stretch you guys a little more. Of course, there's infinite possibilities. If you really want to get creative, it's like, I want to do one way down the road. Like, maybe I'll do something like, I don't know, 13 pi over 6 or something crazy. I don't know if that works, but you could if you want, but why? Keep it simple. There you go. Oh, Ethan, do you have a, I just say you're in the bathroom. Don't worry, you're all good. I got you. But Alex for sure is not here, right? You guys said that. You don't know? Okay, well, we'll find out. So Ethan, I'll just accidentally. So frustrating. Hold on. Let me fix this. Hold on. All right, here you're good. All right, let's keep going. For 37, same thing, but I want A and H to be negative. So just look at the graph and say, okay, well, my A value is 2. My period is 4. So my B is going to be pi over 2. Is that right? B is pi over 2. My K is 2. Now if I do this sine graph, and sorry, A is going to be negative 2. I think it's back. A is going to be negative 2. So I'm going to start back here and doing a sine graph. No, even further back. So I wanted H to be negative and A to be negative, right? So I don't want, if I kind of zoom here. So I kind of let's do that. So that's -1, -2, -3, -4. Graphically, it's supposed to be like this. There's a point right here, right? Point down here. That's a -1, mind you. -2, -3, and -4. That makes sense, right? How I continue that graph. So I'm going to start over here. Because I want H to be negative and A to be negative. You can't do -1 for H because then A would be positive, right? So you got to start over there. So you got to really think hard about that one. And that's why the answer looks like this. Wait, did I mess that one up? Wait, crap. It should be -3, right? Yeah. Okay, well, I messed up. It should be H is -3. My apologies. I really thought I got this one right. So it should be X plus 3. You guys got X plus 3? Okay, good. I feel better. Jeez, I can't believe I made that mistake. I'll have to fix my answer key. All right, I'll fix it. No, for cosine. For cosine, so cosine is going to start at a slow point. If I want a to be negative,
I thought you said h had to be. You said it was +2.
because the form is x minus h.
Oh, so okay, so it's not.
Yeah, because remember it's counterintuitive. Because the form is x minus
Okay,
h.
so when you say you want
Right.
h to be negative,
To the left.
To the left.
that-
Look. I mean, correct. Sorry. Okay. But I got cosine right, so I'm good there. Okay, 38. Okay, I think I got this one right. Okay, A is positive, H is negative. Okay. So for this one here, hopefully I didn't mess this one up either. Period. So first of all, K is 3, guys, right? K is 3. A is 2. But I think we want our H to be negative. Is that right? Mm-hmm. H has to be negative. We'll worry about that in a moment. Period. 1 cycle is pi/4. So what's your B value? 8. Yes, good. So if my H is negative, it's going to start right here. So that's at, isn't that pi rate right here? That peak. And that core point is at pi/16. And over here, that's at negative pi/16. I gotta go further back just a bit more. That's at negative 3 pi/16. So that's why my H is negative 3 pi/16. And then for cosine, it'll be at negative pi/16. Everything else should be fine. Oh, sorry, negative pi/8. My bad. Negative pi/8. My apologies. Be at negative pi/8. Yeah, that should all be fine. So that's the answer for 38. We're okay with that? Okay. The rest, just use Desmos to check your answers, but I can go over any of these if you want me to. And just today's homework quiz is going to be a cosecant graph, just so you know. Sorry, a secant graph. It's going to be pretty close to number 44. Yeah. But any question on 47, 48, 49, 50, how to do that in the calculator or in Desmos? No? We're good? All right. So lunch today starts at 12:15 or 12:25. Hold on. The schedule's so wonky.
wrong.
That's wrong because I didn't feel like updating it because I'm just getting sick and tired of these special schedules. Okay, so let's make sure we go no more than 12:15 for the notes today because I want to kind of get pretty far today. All right, so you guys are cool? We good? All right, glad I didn't spend too much time on that. All right, so let me close. We'll keep that open. Okay, so why don't you guys start? Let's go to page 23 of the notes. We are now ready to venture into inverse trig. Okay. A little bit of review. Horizontal line test. Let me expand it to that. Right. Horizontal line test. What is that for? Why do we use that? Right, exactly. So f and g are inverse of each other if and only if. Right, so f of g of x equals x and g of f of x equals x. The domain of f is the range of g. The domain of g is the range of f. Okay, sorry, my handwriting sucks there. You guys get that right? We're good? Okay. Now, let's look at the graph of sine. We know this, right? Actually, I want to switch to a different color. New color, pink.
Will the inverse of this graph be a function? No, right? Because this fails the horizontal line test. So we have to force the issue. For what interval will y cosine theta have an inverse that is a function? So if I think about it, right now, I failed the horizontal line test, right? I want to force the issue of making this a function. So let's get a highlighter out. Would this portion pass the horizontal line test? What I just highlighted? Yeah, let me turn off the lights because so it's yeah, that portion passes the horizontal line test. And that portion is from what to what? What x values? Correct. So this portion is from pi over 2 3 pi over 2. And what's my range for that? -1 to 1. Exactly. Good. Because are all y values covered now? Yeah. I've covered every single y value for this interval for x. This interval for x guarantees all possible outputs for sine. So I'm good. Plus, if you think about it, it's the left half of the inner circle. On the second quadrant, you have positive sign values. In the third quadrant, you have negative sign values. And you have 0, 1, and -1 all taken care of. So this is good. Okay. So that's my interval. That'll guarantee that the inverse of sine will be a function. They'll pass the horizontal line test only for that interval. If I go any more to the left, any more to the right, forget about it. Okay. Of course, there's other intervals too. How many other intervals can I write? Infinite. Yeah, I could have gone from like 5 pi over 2 to 7 pi over 2 if I wanted to. Or I could have gone from negative pi over 2 to pi over 2 if I wanted to. Actually, let me revise this. Just a tad. And the reason why is because there is a default domain we have to go with. Let me draw more of this graph. Nothing wrong with what I did. Everything was fine. Yeah, I just drew another cycle, right? Not a big deal. Let me highlight this instead. Does that pass horizontal line test? Still does. So this is still valid. And my range would still be the same. So now in this case, I'm focusing on the right half of the inner circle. The first quadrant's covered and the fourth quadrant. This is actually the default domain or default range for inverse sine. We'll talk about that in a moment. This is what most textbooks and calculators will use. They'll use this as a default. So that I was not wrong in highlighting pi over 2, 3 pi over 2, but I should have highlighted negative pi over 2, pi over 2, because that's going to be the default used for inverse sine. Okay, let's do likewise for cosine and tangent, and then we'll really get deep with inverses on the next page. Okay, cosine. We know what's up with cosine, right? Looks like this. Right, by now we're pretty comfortable with that, right? My best to be smooth. Actually, I did okay there. I didn't do too bad. All right, if I do horizontal line test, do I pass? No way. I want to force the issue. I want this to pass. So I should highlight a certain portion of it to make it pass. What can I highlight? Yeah, totally. Did I have to highlight that portion? No. I could then pi to 2 pi, negative pi to 0, negative 2 pi, negative pi. There's infinite possibilities. But we'll do that instead. So my interval is going to be from 0 to pi, which guarantees that y is between -1 and 1. Right? We're good? Cool. All right. All right, then let's look at tangent. Remember, tangent looks like this. Do 3 cycles. Just 'cause I feel like it. You have these little squiggly lines, right? Kind of looks like X cube a little bit. Like a cubic function. Does this pass the horizontal line test? No way. Absolutely not. So we have to force the issue